Okay, so I think in the last class we have explained about the class B amplifier. Okay, now, so in this class we are going to see about this class AB and this class C amplifier. Okay, uh, so is it visible PPT clearly? Okay. So in this class we are going to study initially the introduction for the class AB. It is what actually it is class AB amplifier, what are its advantages and it is what are its disadvantages and applications of the class AB amplifier along with the class AB, and also it is class C amplifier, its working and its advantages and its disadvantages and its applications. Okay, all this is to be get studied in this class here. Okay, now, so in the introduction part, so in the previous classes I already explained about the class A and this class B. Okay, in the class A, it will undergo entire 360-degree. Okay, observe the blue color line here. Okay, so the conduction angle is entire 300, okay, 60-degree here. It is entire full cycle here. But in case of the class B, it is also studied in the previous classes. It is going to conduct for the half cycle here. So the conduction is 180-degree. Okay, and if you take the class AB, so its explanation is available in the name itself, AB. So AB means it should be, it is less than the A and it should be more than the B. Okay, it should be less than the A means it should be within the 360-degree, and it should be more than the B means it should be above the 180-degree. So observe the blue color line here. It is more than the half cycle and it should be less than the full cycle here. And if the operation takes place in this way, it is called as it is class AB amplifier. It is called as class AB amplifier here. So what this conduction angle is in between 180-degree to up to it is equal to 360-degree. Okay, it what this is initial, it should be above 180 to this 200-degree. Okay, and if you take the class C, it should be less than the 180-degree. ಹೌದಾ, ಇನ್ನೊಂದು ಬರೇ ಹೇಳ್ತೀನಿ ಕೇಳ್ರಿ. ಇಲ್ಲಿ ಕ್ಲಾಸ್ ಎ ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಎಂಟೈರ್ 360 ಡಿಗ್ರಿ ಆಗುತ್ತೆ, ಎಂಟೈರ್ ಫುಲ್ ಸೈಕಲ್ ಆಪರೇಷನ್ ಆಗುತ್ತೆ. ಇದು ಕ್ಲಾಸ್ ಬಿ ಅಂತಂದ್ರೆ ಗೊತ್ತಿದೆ, ಇದು ಏನಾಗುತ್ತೆ ಹಾಫ್ ಸೈಕಲ್ ಅಷ್ಟೇ ಕಂಡಕ್ಷನ್ ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನ್ 360 ಏನಿರುತ್ತಲ್ಲ ಇದರ ಅರ್ಧ ಪಾರ್ಟ್ ಅಂದ್ರೆ 180 ಡಿಗ್ರಿ ಕಂಡಕ್ಟ್ ಆಗುತ್ತೆ. ಈ ಕ್ಲಾಸ್ ಎ ಬಿ ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ ಇದು ಎಗಿನ ಕಡಿಮೆ ಆಮೇಲೆ ಬಿ ಕಿನ ಜಾಸ್ತಿ ಅಂತಂದ್ರೆ 180ಗಿನ ಜಾಸ್ತಿ ಆಮೇಲೆ 360ಗಿನ ಕಡಿಮೆ ಇರಬೇಕು. ಅದಕ್ಕೆ 180 ಇಂದ 200ಗಿನ ಹೆಚ್ಚಿಗೆ ಇರಬೇಕು, ಆಮೇಲೆ 360ಗಿನ ಒಳಗಡೆ ಇರಬೇಕು. ಅದಕ್ಕೆ ಏನ್ ಹೇಳ್ತಾರೆ ಕ್ಲಾಸ್ ಎ ಬಿ. ಆಮೇಲೆ ಕ್ಲಾಸ್ ಸಿ ಅಂತಂದ್ರೆ 180 ಡಿಗ್ರಿಗಿನ ಕೆಳಗಡೆ ಇರಬೇಕು. ಓಕೆ, ದಿಸ್ ಈಸ್ ಅಬೌಟ್ ದ ಕ್ಲಾಸ್ ಎ, ಕ್ಲಾಸ್ ಬಿ, ಕ್ಲಾಸ್ ಎ ಬಿ ಅಂಡ್ ದ ಕ್ಲಾಸ್ ಸಿ. ಇಟ್ಸ್ ಓನ್ಲಿ ದ ಇಂಟ್ರೊಡಕ್ಷನ್. So in the class AB configuration, or this conduction angle is slightly more than the 180-degree, it is but it much less than the 360-degree. Okay, and what this transistors conduct for, it is more than the half cycle, it is but it should be less than the full cycle. Okay, it is more than the half cycle but it should be less than the full cycle. So that is called as it is class AB. It's a trade-off between the class A and the class B configuration. ಕ್ಲಾಸ್ ಎ ಮತ್ತು ಕ್ಲಾಸ್ ಬಿ ಮಧ್ಯೆ ಏನು ಆಪರೇಟ್ ಆಗುತ್ತಲ್ಲ ಅದಕ್ಕೆ ಕ್ಲಾಸ್ ಎ ಬಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಅಂಡರ್ಸ್ಟುಡ್? ಓಕೆ, ಸೊ ಅಂಡ್ ಇಫ್ ಯು ಟೇಕ್ ಇಟ್ ಇಸ್ ಕ್ಲಾಸ್ ಎ ಬಿ ಪವರ್ ಆಂಪ್ಲಿಫೈರ್ ಸರ್ಕ್ಯೂಟ್ ಡಯಾಗ್ರಾಮ್. Okay, this is the circuit diagram of the class AB here. Okay, already you know about the class B. It is class B, it is push-pull complementary push-pull amplifier. How the class B complementary push-pull amplifier circuit diagram kalte idere. Okay, previous class alli ಏನಿತ್ತಲ್ಲೇ, so the upper it is going to make use of the NPN transistor, and what is below it is lower, it is going to make use of the PNP transistor in the complementary push-pull. In this case also it is going to make use of the same It is upper, it is going to make use of the NPN transistor, and what is lower, it is going to make use of the PNP transistor. And in this case, what happens, the arrangement of the circuit is same as that of the complementary push pull, but the extra thing it is going to make use of, it is two diodes here. It is diode 1 and diode 2. And if you are using the diodes in this way in the complementary push pull amplifier, it is itself is going to operate as the class AB amplifier. Okay, so what this diode, D1 and the D2 are used to pre-bias the transistor, and what these two transistors allows to conduct the current at a very short time, and it allows the smooth turn of the output waveform at the zero crossing. And what, there will be no instant, it is where it is both the transistor are off simultaneously. ಅಲ್ಲಿ ಏನಾಗಿತ್ತು ಕ್ಲಾಸ್ ಬಿ ಆಂಪ್ಲಿಫೈರ್ ಅಲ್ಲಿ ನಮಗೆ ಅಲ್ಲಿ 0.7 ವೋಲ್ಟ್ ಏನಿತ್ತು ವೇಟಿಂಗ್ ಪೀರಿಯಡ್ ಇತ್ತು. ಇಫ್ ಇಟ್ ಈಸ್ ಅಬೋವ್ ದ 0.7 ಇಟ್ ವಿಲ್ ಎಂಟರ್ ಇನ್ ಟು ದ ಕಂಡಕ್ಷನ್. ಅದಕ್ಕೆ ಕ್ರಾಸ್ ಓವರ್ ಡಿಸ್ಟಾರ್ಷನ್ ಆಗ್ತಾ ಇತ್ತು ಅಲ್ಲಿ 0.7 to 0.7, 0.7 to -0.7, but it has been to be overcome by this, it is class AB. So what these diodes, D1 and the D2 is acting as of, it is pre-bias. It is for the transistor 1 and for the transistor 2. And what these two transistors are allowed to conduct at very short time. It is going to conduct at the very short time, and it allows to smoothen the output waveform at the zero crossing. Okay, in this case it's not undergoes, it is crossover distortion. And what, there will be no instant, it is where it is both the transistor are off simultaneously. ಇವು ಎರಡು simultaneous ಆಗಿ ಆಫ್ ಆಗೋದಿಲ್ಲ. ಬಟ್ ಕ್ಲಾಸ್ ಬಿ ಅಲ್ಲಿ ಎಲ್ಲ -0.7 to +0.7 ಆಫ್ ಇರ್ತಾವೆ ಎರಡು. ಎನ್ ಪಿ ಅನ್ನು ಆಫ್ ಇರುತ್ತೆ, ಆಮೇಲೆ ಪಿ ಎನ್ ಪಿ ಆಫ್ ಇರುತ್ತೆ. ಬಟ್ ಇಲ್ಲಿ ಆ ರೀತಿ ಆಗೋದಿಲ್ಲ. ಇದು ಆನ್ ಇತ್ತಂದ್ರೆ ಇದು ಆಫ್ ಇರುತ್ತೆ, ಇದು ಆಫ್ ಇದು ಆನ್ ಅಂದ್ರೆ ಇಮಿಡಿಯೇಟ್ಲಿ ಇದು ಆನ್ ಆಗಲೇಬೇಕು. ದಿಸ್ ಈಸ್ ದ ಕ್ಲಾಸ್ ಎ ಬಿ. ಓಕೆ, and if you take its waveform representation is once again the same. Along the x-axis and along the y-axis, along the x-axis if you consider the output voltage, along the y-axis if you consider the output current, and if you draw the DC load line, and if the operating point is available just above the cutoff region, ಅಲ್ಲಿ ಕ್ಲಾಸ್ ಬಿ ಅಲ್ಲಿ ಏನಾಯ್ತು, ಎಕ್ಸಾಕ್ಟ್ಲಿ ಆನ್ ದ x-axis in the cutoff region ಅಲ್ಲಿ available ಇತ್ತಲ್ಲ operating point, but ಇಲ್ಲಿ it is above the cutoff region. So in this you can able to see, if you apply the input waveform as the entire 360 degree input signal as in this way, the output waveform you can able to see it is going to appear as in this way here. Okay, it is going to output the entire half cycle, and along with this half cycle it is going to output, it is some extra, it is above the 180 degree. The output is going to appear as in this way here. So in class AB amplifier, what this Q point is positioned, it is to be just above the cutoff. It should be just above the cutoff. How the cutoff irutte on the x-axis, it is just above the cutoff region. It is some part of the negative going half cycles will also be reproduced at the output. Some part of the negative going, how the negative cycle full illa namdu, how the negative cycle one ಸ್ವಲ್ಪ ಇದೆ ನೋಡಿ. Okay, some part of the negative going half cycles will also be reproduced at the output. And what is the amount of the negative going half cycle is to be reproduced at the output is going to be depend upon the amount of the pre-bias is given to the transistor. How much amount of the bias it is going to get, it is to be decided by this diode. If it is implemented with the silicon, it is 0.7 volt, and if it is implemented with the germanium, it is equal to 0.3 volts. What this negative cycle voltage is up to 0.7 if it is for the silicon, and if it is for the germanium, it is to be 0.3 volts. Okay, and what this presence of the small amount of the collector current at the zero input causes reduction in the efficiency. In case of the class B amplifier, the efficiency is equal to 78.5. How the derivation ಮಾಡಿದರೆ? Okay, in case of the class A, it is equal to 25 to 50%. In case of the class AB, the efficiency is above the class A, it should be below the class B. So that means that the efficiency is in between, it is 50 to it is okay 78.5%. The efficiency is going to lie in between the 50 to okay 78.5%. Okay, this is about what the class AB okay graph. Understood? And afterwards, if you take the advantages of the class AB, it is no crossover distortion. It offers the power efficiency and of the good sound. It is no need for the bulky coupling of the transformers. It is no hump in the output. These are the advantages. Andre crossover distortion ಇರೋದಿಲ್ಲ, but efficiency okay ಕಡಿಮೆ ಇತ್ತಂದ್ರು it is going to give you the clear output. And ಏನಾಗುತ್ತೆ ಬಲ್ಕಿ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್ ಯೂಸ್ ಮಾಡೋದಿಲ್ಲ. ಅಲ್ಲೇ ಏನ ಕಾಂಪ್ಲಿಮೆಂಟರಿ ಪುಷ್ ಪುಲ್ ಆಂಪ್ಲಿಫೈರ್ ಅಲ್ಲಿ ಏನು ಯೂಸ್ ಮಾಡಿದ್ರಿ, ಯು ಆರ್ ಯೂಸಿಂಗ್ ದ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಎಟ್ ದ ಇನ್ಪುಟ್ ಸೈಡ್ ಅಂಡ್ ಎಟ್ ದ ಔಟ್ಪುಟ್ ಸೈಡ್, ಬಟ್ ಇಲ್ಲಿ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಯೂಸ್ ಮಾಡೋದಿಲ್ಲ. ಅಂಡ್ ಇಟ್ ಇಸ್ ನೋ ಹಂಪ್ ಎಟ್ ದಿ ಔಟ್ಪುಟ್, ಹಂಪ್ಸ್ ಏನು ಬರೋದಿಲ್ಲ. ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಗಿವ್ ಯು ದ ಕ್ಲಿಯರ್ ಔಟ್ಪುಟ್. And if you take the disadvantages of the class AB, if you take the disadvantages of the what the class AB, the efficiency is slightly less it is when compared to the class B configuration, obviously. Okay, what the conduction angle of the class AB 180 degree irutte, adrada efficiency ಹೆಚ್ಚಿಗಿರುತ್ತೆ, but its conduction is above the 180 degree, so its efficiency is going to be less if it is compared to the class B configuration. And what there will be, it is some okay DC component in the output at the load is to be directly coupled. On using the direct coupling, it is some amount of the DC component it may be available at the output. And what this capacitive coupling, it can eliminate the DC coupling, it is, but it not practical in case of the heavy loads. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಡೈರೆಕ್ಟ್ ಕಪಲ್ಡ್ ಯೂಸ್ ಮಾಡೋದ್ರಿಂದ ಏನ್ ಬರುತ್ತೆ ಡಿ ಸಿ ಕಾಂಪೋನೆಂಟ್ ಬರುತ್ತೆ. ಬಟ್ ನಾವು ಅದಕ್ಕೆ ಡೈರೆಕ್ಟ್ ಓಕೆ ಕಪಲ್ಡ್ ಬದಲಿ ನಾವು ಏನ್ ಮಾಡಬೇಕು, ಕೆಪಾಸಿಟಿವ್ ಕಪ್ಲಿಂಗ್ ಯೂಸ್ ಮಾಡಿಬಿಟ್ರೆ ಅದನ್ನ ಡಿ ಸಿ ಕಾಂಪೋನೆಂಟ್ ಎಲಿಮಿನೇಟ್ ಆಗುತ್ತೆ. ಬಟ್ ಇಟ್ ಈಸ್ ಅಪ್ಲಿಕೇಬಲ್ ಓನ್ಲಿ ಫಾರ್ ದ ಸ್ಮಾಲ್ ಲೋಡ್ಸ್, ಬಟ್ ಫಾರ್ ದ ಹೆವಿ ಲೋಡ್ಸ್ ಅಗೇನ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಟು ಬಿ ಯೂಸ್ಡ್. ದೀಸ್ ಆರ್ ದ ಡಿಸ್ಅಡ್ವಾಂಟೇಜಸ್ ಆಫ್ ದ ಕ್ಲಾಸ್ ಎ ಬಿ. And if you take the applications of the class AB, so it is mainly used for the audio frequency amplification, and it is used for it is a radio frequency amplification, and it is used in the untuned power amplifiers, etc. are the applications of the class AB. Understood? Okay, so important point to be remembered in the class AB, idರಲ್ಲಿ important point remember ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ ಕ್ಲಾಸ್ ಎ ಬಿ ಅಲ್ಲಿ ಇಲ್ಲೂ ಎಷ್ಟು ಟ್ರಾನ್ಸಿಸ್ಟರ್, 2 ಟ್ರಾನ್ಸಿಸ್ಟರ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಒಂದು ಎನ್ ಪಿ ಎನ್ ಆದ್ರೆ ಇನ್ನೊಂದು ಪಿ ಎನ್ ಪಿ. ಇದು ಆಫ್ ಇದ್ರೆ ಇದು ಆನ್ ಇರುತ್ತೆ, ಇದು ಆನ್ ಇದ್ರೆ ಇದು ಆಫ್ ಇರುತ್ತೆ. ಆಪರೇಷನ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಸೇಮ್ ಆಫ್ ದ ಕ್ಲಾಸ್ ಬಿ ಅಲ್ಲಿ ಹೆಂಗ್ ಆಪರೇಟ್ ಆಗುತ್ತೆ ಹಂಗೆ ಆಪರೇಟ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ನಾವು ಎಂಟೈರ್ ಪಾಸಿಟಿವ್ ಸೈಕಲ್ ಇನ್ಪುಟ್ ಕೊಟ್ರೆ ಇದು ಆನ್ ಆಗುತ್ತೆ, ಇದು ಆಫ್ ಆಗುತ್ತೆ. ಆಮೇಲೆ ನೆಗೆಟಿವ್ ಇನ್ಪುಟ್ ಇಲ್ಲಿ ಏನೋ ನೆಗೆಟಿವ್ ಸೈಕಲ್ ಕೊಟ್ರೆ ಅವಾಗ ಇದು ಆಫ್ ಆಗುತ್ತೆ, ಇದು ಆನ್ ಆಗುತ್ತೆ. ಬಟ್ ಎಕ್ಸ್ಟ್ರಾ ಥಿಂಗ್ ಏನು ಯೂಸ್ ಮಾಡಿದ್ದಾರೆ ಇಲ್ಲಿ, ಬಯಾಸಿಂಗ್. ಓಕೆ, ಇಲ್ಲಿ 2 ಡೈವರ್ಸ್ ಯೂಸ್ ಮಾಡಿದ್ದಾರೆ. ಇದು ಕ್ಲಾಸ್ ಬಿ ಆಗಿ ಆಕ್ಟ್ ಆಗುತ್ತೆ. ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಸ್ಮೂತ್ ಅನ್ ದ ಸಿಗ್ನಲ್. ಏನಾದ್ರೂ ಸಿಗ್ನಲ್ ಸ್ವಲ್ಪ ರಫ್ ಇತ್ತಂತಂದ್ರೆ ಅಥವಾ ಡಿಸ್ಟಾರ್ಷನ್ ಇತ್ತಂದ್ರೆ ಇವು 2 ಡೈವರ್ಸ್ ಏನ್ ಮಾಡುತ್ತೆ, ಸ್ಮೂತ್ ಮಾಡುತ್ತೆ. ಓಕೆ, ಅಂಡ್ ಇದ್ರದ್ದು ಕಂಡಕ್ಷನ್ ಆಂಗಲ್ ಈ ರೀತಿ ಇರುತ್ತೆ, 180 ಡಿಗ್ರಿಗಿನ ಸ್ವಲ್ಪ ಹೆಚ್ಚಿಗೆ ಬರುತ್ತೆ. ಸಮ್ ಪಾರ್ಟ್ ಆಫ್ ದ ನೆಗೆಟಿವ್ ಸೈಕಲ್ ವಿಲ್ ಬಿ ಪ್ರೊಡ್ಯೂಸ್ಡ್. ಆಮೇಲೆ ಇದ್ರದ್ದು ಅಡ್ವಾಂಟೇಜಸ್ ಏನಂದ್ರೆ ನೋ ಕ್ರಾಸ್ ಓವರ್ ಡಿಸ್ಟಾರ್ಷನ್, ಎಫಿಷಿಯನ್ಸಿ ಪವರ್ ಬಟ್ ಗುಡ್ ಸೌಂಡ್. ಓಕೆ, ಇಲ್ಲಿ ಬಲ್ಕಿ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಯೂಸ್ ಮಾಡೋದಿಲ್ಲ, ಹಂಪ್ಸ್ ಇರೋದಿಲ್ಲ. ಆಮೇಲೆ ಇದ್ರದ್ದು ಡಿಸ್ಅಡ್ವಾಂಟೇಜಸ್, ಎಫಿಷಿಯನ್ಸಿ ಓಕೆ ಲೆಸ್ ಇರುತ್ತೆ. ಆಮೇಲೆ ಏನಾಗುತ್ತೆ ಡಿ ಸಿ ಕಾಂಪೋನೆಂಟ್ಸ್ ಬರುತ್ತೆ ಔಟ್ಪುಟ್ ಅಲ್ಲಿ. ಆಮೇಲೆ ನಾವೇನಾದ್ರು ಕಪ್ಲಿಂಗ್ ಕೆಪಾಸಿಟರ್ಸ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಅಪ್ಲಿಕೇಬಲ್ ಓನ್ಲಿ ಫಾರ್ ದ ಸ್ಮಾಲ್ ಲೋಡ್ಸ್, ಫಾರ್ ದ ಹೆವಿ ಲೋಡ್ಸ್ ಇಟ್ಸ್ ನಾಟ್ ಯೂಸ್. ಅಪ್ಲಿಕೇಶನ್ಸ್ ಏನಂದ್ರೆ ಆಡಿಯೋ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಮೇಲೆ ರೇಡಿಯೋ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅನ್ಟ್ಯೂನ್ಡ್ ಆಂಪ್ಲಿಫೈರ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅಂಡರ್ಸ್ಟುಡ್? ದಿಸ್ ಈಸ್ ಅಬೌಟ್ ದ ಕ್ಲಾಸ್ ಎ ಬಿ ಆಂಪ್ಲಿಫೈರ್ಸ್. Is there any doubt in this one? Is there any doubt in this one? ಆನ್ಲೈನ್ ಇದೆಯಲ್ಲ, ಏನಾದರೂ ಡೌಟ್ ಇದೆಯಾ? ಓಕೆ. If you take the class C amplifier, what this class C amplifier I said, again if you take the graph of the along the x-axis, if you take the VCE voltage, output voltage, and along the y-axis if you take the current, and if you draw the DC load line here, and if the operating point is available below the cutoff region, it is below the x-axis, and if you apply the entire input signal as in this way, okay, if you apply the entire input cycle, entire full cycle, so that you can able to get only the output which is to be less than the 180 degree. So this part of the output is going to be appear, and if you take okay from at this point to at this point, and from at this point to entire positive cycle, I'm sorry, entire negative cycle, it is going to be clipped off. And if you get the output as in this way, ಅಂದ್ರೆ 180 ಡಿಗ್ರಿಗಿನ ಕಡಿಮೆ ಬಂತಂದ್ರೆ ಅಥವಾ ಹಾಫ್ ಸೈಕಲ್ ಇಂದ ಕಡಿಮೆ ಬಂತಂದ್ರೆ ಅದಕ್ಕೆ ಏನಂತ ಹೇಳ್ತಾರೆ, ಕ್ಲಾಸ್ ಸಿ ಆಂಪ್ಲಿಫೈರ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ಇನ್ ದ ಕ್ಲಾಸ್ ಸಿ ಪವರ್ ಆಂಪ್ಲಿಫೈರ್, ಸೊ ದ ಆಕ್ಟಿವ್ ಎಲಿಮೆಂಟ್ is going to conduct for less than this 1/2 cycle of the input signal, or this conduction angle is less than the 180 degree, and its typical value is 80 degree to 120 degree. 180 degree ಕಡಿಮೆ ಇದೆ ಅಂತಂದ್ರೆ ಎಷ್ಟು ಇರ್ಬೋದಪ್ಪ, ಮತ್ತೆ 0 degree 1 degree 2 degree ಇರೋದಿಲ್ಲ. It is approximately 80 degree to 120 degree. Okay, and what this reduced conduction angle improves the efficiency to a great extent. It is, but it causes a lot of the distortion. Okay, the efficiency will be more. Okay, increasing in the angle is going to decrease the efficiency. ಹೌದಾ? ಅಲ್ಲಿ ಕ್ಲಾಸ್ ಎ ಅಲ್ಲಿ ಎಷ್ಟಿತ್ತು ಇದು ಆಂಗಲ್ ಕಂಡಕ್ಷನ್ ಎಂಟೈರ್ 360 ಇತ್ತು, ಬಟ್ ಅಲ್ಲಿ ಎಫಿಷಿಯನ್ಸಿ ಕಡಿಮೆ ಇದೆ. ಎಷ್ಟಿದೆ 25 to 50 ಇದೆ. ಓಕೆ, ಆಮೇಲೆ ಕ್ಲಾಸ್ ಬಿ ಅಲ್ಲಿ ಎಷ್ಟಿದೆ 180 ಡಿಗ್ರಿ ಇದೆ, ಎಫಿಷಿಯನ್ಸಿ ಎಷ್ಟಿದೆ 78.5 ಇದೆ. ಅಂದ್ರೆ ಕಂಡಕ್ಷನ್ ಆಂಗಲ್ ಕಡಿಮೆ ಆಗೋದ್ರಿಂದ ಎಫಿಷಿಯನ್ಸಿ ಇನ್ಕ್ರೀಸ್ ಆಯ್ತು. ಆಮೇಲೆ ಕ್ಲಾಸ್ ಎ ಬಿ ಅಲ್ಲಿ ಎಷ್ಟಿದೆ, it should be above the 180 degree, it should be below the 360 degree. ಅದೇ ರೀತಿ ಎಫಿಷಿಯನ್ಸಿ ಎಷ್ಟಿದೆ, above the 50%, it should be less than the 78.5. ಇಲ್ಲಿ ಕ್ಲಾಸ್ ಸಿ ಅಲ್ಲಿ it is going to conduct less than the 180 degree, so that efficiency is, it is more than the 78.5%. The efficiency, okay, what this reduced conduction angle improves the efficiency to a great extent, but it causes a lot of the distortion. ಸಿಗ್ನಲ್ ಏನಾಗ್ಬಿಡುತ್ತೆ, ಕಟ್ ಆಗುತ್ತೆ ಅಷ್ಟೇ, ಬಟ್ ಎಫಿಷಿಯನ್ಸಿ ಏನಾಗುತ್ತೆ, ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಓಕೆ, what this theoretical, the maximum efficiency of the class C amplifier is around 90%. ಓಕೆ, ಕಂಡಕ್ಷನ್ ಆಂಗಲ್ ಕಡಿಮೆ ಆಗೋದ್ರಿಂದ ಎಫಿಷಿಯನ್ಸಿ ಎಷ್ಟಾಯ್ತು, ಹೆಚ್ಚಿಗೆ ಆಯ್ತು. And what this operating point is placed, it is okay, somewhere it is below the cutoff point. Nodil, operating point, it should be below the x-axis, it should be below the cutoff, okay, cutoff point in the dose, in the DC load line, and so only a fraction of the input waveform is available at the output. Only the fraction of the input is available at the output. Okay, this is about the class C amplifier. And if you take the circuit diagram of this one, okay, this is the circuit diagram of the class C amplifier. Okay, so it is going to make use of the only one transistor, and it is what this resistor is to be connected at the base. So I am going to call this as an RB, and across the collector it is to be connected with, it is one capacitor and it is one inductor in the parallel combination. In case of the class A, in case of the class B, in case of the class AB, so that you are using only the resistors as the load. But in case of the class C, so that you are using a tank circuit. The arrangement of the C and L in terms of the parallel is acting as, okay, tank circuit. This is called as okay tank circuit, and other end of these two is to be connected for the VCC here. This is the circuit diagram of the class C amplifier. In the class C power amplifier, it is reverse bias the base emitter okay, junction of the transistor. So the transistor is biased okay deep into the cutoff, and what this transistor will not conduct until the input signal overcomes the reverse bias. Obviously, until unless its conduction angle is to be less than the 180 degree, it will not enter into the conduction. In order to be less than the 180 degree means it should overcome okay reverse bias. After entering into the forward bias only, it is going to start the conduction. Okay, inductor L1 and okay the capacitor okay C1 is going to form a tank circuit which aids in the extraction of the required signal from the pulsed output of the transistor. It is whatever the output you are going to get is to be okay, it is to be get operated by okay so this capacitor and the inductor in order to acting as an oscillator here. Okay, so it is being the resistor RB is going to pull the base of the Q1, it is further okay downwards, and the Q point will be set the some way it is below the cutoff point in the DC load line. Namdu operating point okay DC load line kina kelagade, I am sorry that okay cutoff point kina kelagade barbekandre it is to be taken care by this RB resistor. ಇದರ ಆರ್ ಬಿ ರೆಜಿಸ್ಟರ್ಸ್ ವ್ಯಾಲ್ಯೂಸ್ ನಾವು ಅದನ್ನು ಯಾವ ರೀತಿ ಚೂಸ್ ಮಾಡ್ತೀವಿ ಅದರ ಮೇಲೆ ಆಪರೇಟಿಂಗ್ ಪಾಯಿಂಟ್ ಏನಾಗುತ್ತೆ ಬಿಲೋ ದ ಕಟ್ ಆಫ್ ಬರುತ್ತೆ. ಓಕೆ, ಅದೇ ಇದೆ ನೋಡಿ ಸೆಂಟೆನ್ಸ್. ವಾಟ್ ಇಟ್ ಇಸ್ ಬಯಾಸಿಂಗ್ ದ ರೆಜಿಸ್ಟರ್ ಆರ್ ಬಿ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಪುಲ್ಸ್ ದ ಬೇಸ್ ಆಫ್ ದ Q1 okay is further okay downwards, and the Q point will be set the some way it is below the cutoff point in the DC load line. RB is going to take care of adjusting the operating point, it is below the cutoff. The actual job of the active element here is to produce a series current pulses according to the input and is going to make it flow through the resonant circuit. What this resonant circuit? It is the combination of an inductor and the capacitor, and it is so the distortion is going to be caused by the amplifier has okay little effect on the final output. Okay, it is what is values of the L1 and the C1 are so selected that okay what this resonant circuit oscillates in the frequency of the input signal. You must inductor value amale capacitor value ಏನು ಬೇಕದನ್ನ okay ಆಯ್ಕೆ ಮಾಡ್ಕೊಳ್ಳಂಗಿಲ್ಲ. It should be selected in a particular way that it is going to get oscillate with the input frequency. ನಾವಿಲ್ಲಿ input ಏನು ಕೊಡ್ತೀವಲ್ಲ it should be get able to oscillate with this input signal. According to that, the value of the capacitor and the inductor is to be get adjusted or is to be selected. C1 and the L1 is to be selected according to the resonant circuit oscillates in the frequency of the input signal. It is since okay what this resonant circuit oscillates in one frequency, all other frequencies are attenuated, and what is required frequencies can be squeezed out usually using a suitable tuned okay load. It is going to be get tuned for the adjusted frequency for a single frequency. It is not going to change. This is all about the class C. Okay, and if you take the advantages of the class C amplifier, it is having the highest conversion frequency and it is having an excellent in RF applications, means in the radio frequency. RF antandre radio frequency applications. It is the lowest physical size for a given power output. Its implementation or it is what the space it is going to consume is of very small in size. If you take the disadvantages of the class C amplifier, it is the lowest linearity and it is going to reduce the dynamic range. It creates a lot of the RF interference. Okay, radio frequency interference may occur. It is difficult to obtain the ideal inductors and okay coupling transformers, and it is due to the huge amounts of the distortion what this classic configuration are not used in the audio applications. It is having okay lot of the distortion, so it is not used in the audio applications. Apart from this, it is used for the other purposes in the radio frequency. And if you take the applications of the Class C amplifier, it is used in the radio frequency oscillator, it is used in the radio frequency amplifier, it is used in the frequency modulator, okay, transmitters, it is used in the booster amplifier, it is used in the high frequency repeaters, used in the tuned amplifiers, etc., etc., etc. In a number of the applications it has been used. Okay. And if you take the sample, okay, descriptive questions on this concept is, he may ask you to explain the Class B amplifier, or he may ask you to list the advantages and the disadvantages of the Class B amplifier, or he may ask you to explain the Class C amplifier and its advantages and disadvantages of the Class C, or he may ask you to list of the applications of the Class AB and its Class C amplifier. These are the possible questions of the Class AB and the Class C concept. Is there any doubt? Okay, 15 members login ಆಗಿದ್ದಾರೆ. Is there any doubt? So okay, thank you. Okay, thank you very much.